What's up everyone? Welcome to Math Mechanics. I am Vignesh. Today we're going to be solving a super intimidating problem, but it's actually very fun once you know how to solve it. Factoring a fourth degree polynomial when the root is complex. We're going to be solving using synthetic division and long form division method. I'm going to walk you step by step so you know how to solve it. Let's waste no more time and get started. Here, I have factorize minus 2x to the power of 4 minus 13x cubed minus 95x squared minus 39x plus 45 is equals to 0. And my complex root is minus 3 plus 6i. So we will perform the synthetic division first. Let's write minus 3 plus 6i and write the coefficients. We will just follow the same process as we do for our real roots. So minus 2 minus 13 minus 95 minus 39 and 45. Okay, so we start by writing 0 here. So minus 2 plus 0 is minus 2. Minus 3 plus 6i times negative 2. So we're going to multiply this with this, right? So minus 3 plus 6i times minus 2 is minus 3 times minus 2 is positive 6, and 6i times minus 2 is minus 12i, right? Okay, minus 13 plus 6. Now we're going to add minus 13 and 6, so that is minus 7 and minus 12i. Okay, now we gotta multiply minus 3 plus 6i and minus 7 minus 12i. So multiplying two complex numbers. So let's do that here. Minus 3 plus 6i times minus 7 minus 12i, right? So minus 3 times minus 7 is positive 21, and minus 3 times minus 12 is positive 36i. And let's do the same thing with 6i. 6i times negative 7 is negative 42i. 6i times negative 12 is negative 72i square, right? So 21 and 36 minus 42 is minus 6, right? And minus 72i square. I square value is negative 1. So minus 72 times minus 1. So that becomes positive 72. So it is 21 plus 72, which is 93 minus 6i. So we're going to take this 93 minus 6i and plug it over here. So 93 minus 6i. Minus 95 plus 93 is minus 2 minus 6i. Okay, so now we will multiply minus 3 plus 6i with minus 2 minus 6i. Same process. Minus 3 plus 6i and minus 2 minus 6i. Okay, so minus 3 times minus 2 is positive 6, and minus 3 times minus 6i is positive 18i. Minus 6i times minus 2 is minus 12i, and 6i times negative 6i is negative 36i square. 18i minus 12i is positive 6i, and minus 36i square is minus 36 times minus 1. So 6 plus 36 and plus 6i. 6 plus 36 is 42 plus 6i. Okay, let's take this value and plug it in our process. 42 plus 6i. Minus 39 plus 42 is 42 minus 39 is 3 and positive 6i. Okay, so minus 3 plus 6i and 3 plus 6i now. Minus 3 plus 6i and 3 plus 6i. If you see this one, this is in the form of a and b, right? A plus b times a minus b. So if I consider 6i to be my a and minus 3 to be my b, so, or maybe 3 to be my b and minus 3 will be minus b, right? So it is like a plus b times a minus b, which is a square minus b square. So it is going to be 6i whole square minus 3 square. So 6i square is 36i square, and minus 3 square is minus 9. 36i square is minus 36 minus 9. So it is minus 45. Okay, so let's go back, and this is our minus 45, and 45 minus 45 is 0. So this is our remainder, right? This has to be 0, right? Because minus 3 plus 6i is a root for this given polynomial. So the final value has to be 0. Okay, now what? Now, if the thing about complex roots is, if a complex root is a solution for your polynomial, then its conjugate will also be the solution for the polynomial. So if minus 3 plus 6i is a solution, then minus 3 minus 6i, which is the conjugate for minus 3 plus 6i, will also be a solution. So we will apply the same process, synthetic division, for minus 3 minus 6i. Okay, so let's do that. Minus 2 and 0 is minus 2. Minus 3 minus 6i times minus 2 is positive 6, and minus 6 positive 12i. So minus 7 plus 6 is minus 1, and minus 12i plus 12i gets cancelled, right? So that makes our job a little bit easier. And then again, minus 3 minus 6i times minus 1, so that is positive 3 and positive 6i. Now minus 2 plus 3 is 1, and 6i minus 6i gets cancelled again. Okay, perfect. Minus 3 minus 6i times 1, which is minus 3 minus 6i. Again, 6i minus 6i gets cancelled. 3 minus 3 is also 0. So both of them get cancelled. So we got another remainder. So indicating that minus 3 minus 6i is also the solution for our polynomial. So these are your coefficients for your quadratic, the factor, right? So let's write that in the quadratic form. Think it is minus 2x square minus x plus 1. So that is your quadratic. Now what will be the other ones, right? So if we write that x minus 3 plus 6i, and x, let's move this a bit, x minus 3 or plus 3, or no, minus 3 minus 6i, the conjugate and the complex number. So those, if you multiply these two again, you will get a quadratic. So let's multiply and get our factored form. So x minus of minus 3 is x plus 3 and minus 6i, and same thing, x plus 3 plus 6i times minus 2x square minus x plus 1. No change there, just a drop down. So consider x plus 3 as a and 6i to be b. So it is again in the form of a minus b times a plus b. So apply your formula a square minus b square. So it is going to be x plus 3 whole square minus 6i whole square. So it is minus 2x square minus x plus 1, again drop down. So let's expand that. X plus 3 whole square, x square plus 6x plus 9, and minus 6i whole square is minus 36i square. So minus 22x square minus x plus 1. So a square value is negative 1, so it is 9 minus of minus 36 plus 36. So this thing will become 45. 9 plus 36 is 45. So minus 2x square minus x plus 1, right? So this is your factored form of your original polynomial, right? So that wraps up our synthetic division method. We can solve the same thing using the polynomial division, long form polynomial division. So let's do that and compare basically like what are the challenges we face, right? So let's do polynomial or long form division method here. So how to proceed with the long form division? We are given a complex root minus 3 plus 6i, right? Minus 3 plus 6i is given to us, and I am also saying minus 3 minus 6i, which is the complex conjugate, is also a solution. So so the if you multiply x minus 3 plus 6i and x minus 3 minus 6i, right? So this will be your divisor. So whatever the quadratic that you're getting, we already did this, so we will take whatever the result that we have here, which is x square plus 6x plus 45. So x square plus 6x plus 45, right? So we will use this as a divisor and the original polynomial as a dividend and get our quotient, right? Okay, so let's do that. Let's move this x square plus 6x plus 45 to the left a bit and write our original polynomial equation. I believe it was minus 2x to the power of 4 minus 39. I want to double check before I write it up. Minus 2x power 4 minus 13x cube minus 13x cube minus 39 x square, or minus 95x square minus 39x plus 45. Okay, so let's write our quotients on the top and bring this down a bit so we have enough space for the quotient. Okay, so let's perform our long form division. So first thing is minus 2x power 4, so I gotta multiply x square with minus 2x square, right? So minus 2x to the power of 4, 6x times minus 2x square is gonna be minus 12x cube. 45 times minus 2x square is minus 90x square. So now you're subtracting both of them, so put a minus in between. What it is minus 2x to the power of 4 minus of minus, so these two gets cancelled. Minus of minus makes it a plus 2x power 4. So the simplified version is, what I like to do is basically change the signs, because minus times minus is plus, and then minus times minus is again plus, minus times minus is plus. So what I like to do is just change the signs at the bottom and solve it. Okay, minus 2x power 4 plus 2x power 4 minus 13x cube plus 12x cube, which is minus x cube, plus 95x square minus 90x square, so that is plus 5x square, and we will drop down this minus 39x for us for our next step. Okay, so now I gotta remove that minus x cube, so I will multiply with minus x. So it is minus x cube plus 6x times minus x is minus 6x square. 45 times minus x is minus 45x. So again I'm subtracting, so that means change the signs. Minus x cube plus x cube gets cancelled. 5x square plus 6x square is 11x square. Minus 39x plus 45x is 5 and 1, so it is plus 6x. Okay, 5x square plus 6x square, 11x square, and finally I'm gonna drop our 45, right? Did I make a mistake? Feel like 11x square is something wrong. 6x minus 6x, because it has to be a negative 1 or a positive 1, because the last one has to be positive one. Okay, let's check if I made any mistake here. Minus 95 plus 90, here. So it is not positive, but it is negative 5x square. So negative 5x square, positive 6x square, that will give us positive x square. Okay, now we are back on track again. Okay, now in order to remove that x square, all you have to do is add plus 1. So it is our answer. So x square plus 6x plus 45. So now we will subtract them. X square minus x square 0, 6x minus 6x is 0, 45 minus 45 is 0. So that is your remainder, and this is your quotient, right here. So all we can say is the factored form of our given polynomial is x square plus 6x plus 45 and minus 2x square minus x plus 1. This is your quotient, right? So this is your final answer. And that's how you factor a fourth degree polynomial using synthetic and long form division. Comment down which method you prefer. If you like this video, hit that like button and share it with your friends. For more math breakdowns like this, subscribe to Math Mechanics. Thank you for watching. Signing off now. See you in the next video.